Right, grades, let's have a look at the exercise 8 in the memo and write some notes as we go. First of all, it says simplify the following, give your answer in exponential form. Now that just means that if you have numbers, you can leave them with exponents. So 2 cubed you could write as 8, but this says you can leave it as 2 cubed. Okay, let's look at the first one. This one is meant to be a bit of an easy introduction. I'm just multiplying, so I think to myself, signs, numbers, variables. There's no real signs, and the only number that there is 2. But when I multiply powers the same base, I add my exponents. So I get 2 to the power of 7. Okay, so that one is quite nice and easy. Next one's also not too bad because there's not much going on. I'm dividing, and when I divide, it's signs, numbers, variables. Now there's no real signs, but just be careful. We've had this example before. 3 goes into itself once, and it goes into 6 twice. So my numbers, it's not 2, but it's 1 over 2. Then if I have a look at my letters, if there's 3 x's at the bottom but 2 on the top, there'll be 1 left over and it'll be at the bottom. And if there's 4 y's on the top but 2 on the bottom, there'll be 2 left over and they'll be left at the top. So that was kind of like a law 2, except I don't like to think of it as a law 2. I like to think about it a little bit more logically. Now again, this 1, I've said this multiple times, that 1 doesn't have to be there. It can be. It doesn't really matter. Okay, let's have a look at C. This is a recap of laws 3 and 4 because everything is being cubed. So this would be negative 3 is being cubed. And then when I raise a power to another power, I multiply those exponents. Now this particular question said that you could leave it in exponential form. So if I was going to leave it in exponential form, I could leave it like that. Now technically I should probably think about it. A negative times a negative times a negative is a negative. 3 cubed. If you want to leave it in exponential form, you can just write 3 cubed. And then x to the power of 6. Now I don't think that's actually particularly neat. So personally, I would have worked out 3 cubed, which is 27. And give you, rather than writing it as 3 cubed. Just looks a bit better as 27. We tend to only leave things in exponential notation if the exponent is big. And so, for example, if you had 3 to the power of 10, that number would be so big that it doesn't make sense working it out. Now just make sure that you find it as negative. That's because technically negative 3 cubed is negative 3 times negative 3 times negative 3, which means you have 3 negatives, which makes a negative. Okay, now we get to something which is a little bit more chunky. Don't forget to go step by step. First thing, deal with your brackets. So I'm going to distribute my exponent of 4. I get 2 to the power of 4, which is 16. I get, when I raise a power to another power, I multiply, and then y to the power of 4. So I've dealt with my bracket on top. On the bottom, I've also got a bracket, and I'm going to have to distribute. So it's x to the power of 7. And then when you raise a power to another power, you multiply. So that was our first step. Our first step was to deal with the brackets. Our second step, if you remember from our notes, is to simplify the top, which actually nothing can be done. But the bottom can be simplified, because if I have 7 x's and then another 7 x's, you actually have 14 x's. And then finally, you can now divide. So signs, numbers, variables. 16 divided by 4 is 4. If I have 12 x's on the top but 14 at the bottom, I'm going to have 2 left over, but they'll be at the bottom. And if I have 4 y's on the top but 14 at the bottom, I'm actually going to have 10 left over and also at the bottom. So actually all my variables were left over at the bottom. Right, E is written in quite an interesting way. I personally would have written this as it was a fraction sign. So my first step would be to write this as something a little bit more familiar to myself, which is that. And now there are no brackets, so I just need to divide signs, numbers, variables. A negative divided by positive is a negative. 15 divided by 5 is 3. If there are 4 m's at the top and 8 at the bottom, 4 will be left over at the bottom. And if there's 2 n's at the top and 2 n's at the bottom, there'll be none left over. And so my answer is actually quite neat. Okay, f looks a little bit interesting. The reason why f's interesting is that it's a fraction times a fraction. Now this is quite annoying, but don't forget that when you do fractions and you're multiplying them, it's top times top and bottom times bottom. So that would be a different way to write exactly the same question. Now the moment I write it like that, it's just so much less threatening. Now there's no brackets to deal with, but I'm going to simplify the top. 5 times 3 is 15. X to the power of 3 and another one is 4. Y squared. And the bottom I can write more neatly as x is first and then y. And then finally I'm dividing, so no signs to speak of. 15 is my only number, but 4x's on the top and 4x's at the bottom means all of them disappear, and 2y's on the top and 1 at the bottom means I have 1 left over at the top. Okay, on to G. G, also quite an interesting question. We just got to take it step by step. So firstly, let's always deal with our brackets. When I raise a power to another power, I multiply. When I raise a power to another power, I multiply. Now, those words that I'm saying to myself, those are the types of things that you need to be talking yourself through in an exam. You should always be talking to yourself. So this is distribution. I get a to the power of 4 and b to the power of 4. Now notice I didn't put this in a bracket. I could have, but I'm just multiplying them and they're next to each other anyway. So it doesn't really matter. And the 2 didn't have anything interesting. So there we go. Right, now I'm going to simplify the top. When I multiply powers the same base, I add exponents. So it's a to the power of 8, b to the power of 10, over negative 2, a squared, b cubed. Okay, now I'm dividing. So signs, numbers, variables. A positive divided by a negative is a negative. Now it doesn't really matter where you put that negative. You can either put it on the top of the fraction or next to the fraction. We just don't like it being at the bottom. Now, there's still just a 2 at the bottom. There's no other numbers to work with that 2. So my letters, if I have 8 A's at the top and 2 at the bottom, I'm left with 6 at the top. And if I have 10 B's at the top and 3 at the bottom, I'm left with 7 of them, and they'll be left at the top. Now, you could have put a little invisible 1 there if you wanted to, but you don't have to. Right, let's have a look at H. H is one of these questions that we did in the notes where an entire bracket is being squared. So you can distribute the square to everything in the bracket and then simplify, but our life is made a lot simpler if we just simplify the bracket first and then square. So let's try that route. A positive divided by a negative is a negative. 15 divided by 5 is 3. 5x is at the top, 3 at the bottom, leaves me with 2 at the top. 1y at the top and 6 at the bottom leave me with 5 at the bottom. So now that I've simplified within the bracket, I can go and distribute. So everything in the bracket, negative 3 gets squared. Careful, it's negative 3 in a bracket squared. Raising a power to another power, multiply. Raising a power to another power, multiply. And lastly, just to neaten that up, negative 3 squared. This did say we could leave it as exponential notation. But again, that's probably a little bit neater if I just change that to a negative times a negative is a positive. So it's 9 x to the power of 4 over y to the power of 10. So again, something that looked quite threatening lands up being quite easy. Right, I is a very similar type of question. So I'm assuming that you've now simplified inside the bracket first. So that's negative 2. There's 3 a's at the top, 1 at the bottom. So 2 will be left at the top. And there'll be 1b left over at the bottom. And I'm cubing. So now I can distribute my cube. So it's negative 2 cubed. When I raise the power to another power, I multiply. And my b also gets cubed. And again, I would work out what negative cubed is. It's fairly easy. It's negative 8, a to the power of 6 over b cubed. Last one was J. Also a very similar question in that I'm going to simplify inside the bracket. So negative 3 at the top, 1 at the bottom leaves me 2x's at the top. 7 at the bottom, 4 at the top leaves me with 3 at the bottom. And z to the power of 7 because 8 at the bottom and 1 at the top. And now I can square, and now I need to be a little bit careful because there's no such thing as a negative. What is that negative actually being? That negative is technically an invisible -1. So technically this is now -1 must be squared. When I raise a power to another power, multiply. When I raise a power to another power, multiply. Raise a power to another power, multiply. And -1 squared is 1. So either you can write in 1 or you can completely ignore it. And there's my answer. So really exponents are best approached by simply breaking it down and going step by step. Slowly is far better with exponents. And also you've got to remember that they look a lot worse than they'll end up being. Okay, well done.